All right, my friends, let's take a look at example 1. It says, find the area enclosed by the curve r equals 4 sine theta using A, geometry only, because it turns out this is a perfect circle, so you could just do a little pi r squared on it. And then B, making sure you can use the formula that we talked about to do this using calculus. So particularly important for the calculus piece would be graphing it. So let's go ahead and get started on that. So let's do a little t-table work. We do know going in, just based on the form, that that's a circle of diameter 4. So let's go ahead and plug in 0 for theta, we'd get 0 out. Plug in pi over 6, we would get 2 out. Plugging in pi over 2, we would get 4 out. Plugging in 5 pi over 6, we'd get 2 again. And then plugging in pi, we'd get 0 again, and so the circle has essentially closed out. So filling it in with your best shot at a perfect circle.
Ooh.
No pressure, Bryce.
That's really bad. Okay.
Okay, we all have imaginations, and we're gonna start using it right now on that circle. Okay, let's all pretend that's a perfect circle. Now a comment, my friends, for the angle measures from pi to 2 pi. If you plug those in, starting with 7 pi over 6, you'll notice you get negative r values. So this circle draws itself twice if you go from 0 to 2 pi. The reason that's important, my friends, is because when it comes to calculus, we're going to need to use appropriate bounds to find the area once and not the area twice. All right, so starting with geometry, just a little pi r squared. There we go, easy peasy. We have the area in the future. Unless somebody says, make sure you use calculus, I hope you'll just use geometry on it. But for the point of learning, let's go ahead and show that you can get the same answer using calculus. So starting just with the formula in general for area in polar form. Area is 1/2 times the integral from alpha to beta of r squared d theta. All right, now replacing r with the appropriate function rule in terms of theta. Oh, and also putting the bounds, thank you. So we're gonna go from 0 to pi so that you get the area once and you don't get it doubled. R is defined as 4 sine theta in this problem. There we go. All right, now it's a matter of, do you remember how to do this integral? Good, square it out. Then factor the 16 out and multiply it by the 1/2, we'll have 8. All right, now for integrating either sine or cosine to an even power like this, we'll need to try to remember the power reducing identity for sine. So sine squared theta is equivalent to 1 minus cosine 2 theta all over 2. Nice. Dividing the 2 in. And then just doing the antiderivatives. So you'd have 8 times, good, 1/2 theta minus, now it's up to you if you guys want to do u substitution or kind of think it out in your head. But you should get 1/4 sine of 2 theta. Evaluating it from 0 to pi. All right, my friends, plugging pi in. then plugging 0 in. Good. And then a comment here, everybody, sine of 2 pi is 0 and sine of 0 is 0. So most of these terms equal 0. The only ones that don't would be, or the only one that doesn't, would be that 1/2 pi there. All right, so a ton of unnecessary calculus on this particular problem, but you gotta admit, it feels kind of good to get the correct answer that you got in half a step with geometry. There you go.